Alright, hello everyone. I'm coming to you from a beautiful Wednesday afternoon on the east coast of the US. My name is Josh Joseph, and along with my friend Neha Pedinti, I'll be presenting the web development course here at Code for Tomorrow. So before we get started, I would like to show you this transcript right here. It's just a series of notes about how the course will run. This will either be in the description of this video or somewhere where you'll be able to access it. And I'd like you to just quickly skim over this before we start the video. So you can pause the video here. I just quickly scrolled through it and just take a look at it. I added some notes too that you'll have to know before we get into this. So as you can see, I'm at the course introduction and we're going to introduce the course and how this will run. So this course is going to be run in a series of 6 chapters with these slides. 6 chapters over here, from Intro to Web Development all the way to Advanced CSS. So you can see we're learning HTML and CSS over here. So before we actually get into the material, I'd like to just make sure that everyone is good with Discord. You've created your Discord accounts and signed into the C4T student server. You followed all the instructions and everything's good with that. If not, just pause the video here and type this link into your browser and just hit that, and then Discord will let you do the rest. Of course, I'm not sure if this link is 100% up to date since that's changed every now and then. And as of taping this video, that might have changed as well. So if this link doesn't work, just get the link from somebody at C4T. They'll be able to direct you for where you need to go. So all right, let's get started. Actually, before we get started, let me talk about Thinkific. Thinkific is basically a curriculum hosting platform where we host a lot more in-depth versions of the curriculum that I'm going to teach you. Of course, I have to squeeze an entire chapter into a single video, so I'm going to be simplifying a few of the processes that I'm going to be talking about just so you can understand kind of on the first glance, first look. So, but if you go into here, like if you pick a random chapter and go into here, it goes into a bit more depth than I do. All right, when this loads up, my internet's not really the best over here. Let's pick one of these. There we go. All right, so yeah, you can see how it goes into a lot more depth, but it's still something you can read. And if you have any questions about any of the content here on Thinkific, just ask your teacher or anyone at C4T that can direct you to a person that'll probably know the answer to what you're talking about. Anyway, let's move on to the actual content of today's lesson, which is chapter 1, the internet. So of course, before you understand much of web development, you have to understand how the internet works. And that starts with the most basic unit of content on the internet, which is a website. And a website is just a text file with a bunch of code. So this is just this entire site right here, any site, Google, Yahoo, YouTube, even apps, but apps are a little bit different. But websites are made up of code. They're just files of code. Just like if you've visited Java files and Python files, when you run those, they're just text files with a bunch of code in them. And a website, so an entire website like google.com, is a collection of a bunch of web pages. Like it's a home page, a page about cats, a page about the author of the website. So here's different ways that a website actually is made up. So you start with an HTML code, which is the structure and content of your website, kind of the skeleton, like the exact text that's following. So this is going to be made with HTML, so is this. Just basically the text and where everything is. And then if you want to add color, spice it up, add style, kind of the meat of your web page would be CSS. It stands for Cascading Style Sheets, and that's exactly what it is. It's a sheet that determines the style of the page. So you can see all the color that's happening here, all the effects when I'm moving over and clicking on things. That's done through CSS. And then lastly, you have JavaScript, and that's adding functionality. It makes things actually work. For example, when I press the share button on Google Slides, this was implemented via JavaScript, and I hit done, goes back. I can hit a bunch of these buttons. These are all implemented using JavaScript. That's what makes websites actually work. Like if you're logging into your Google account, for example, that's done through JavaScript. So in this particular course, we'll be focusing on teaching you HTML and CSS. So let's move on to how the internet actually works. So how do you actually access websites? So remember, we talked about that a website is just a bunch of code in a file. And then if you run that HTML, CSS, and JavaScript code all together in your browser, that is what make all these cool websites appear and all these cool videos and graphics. But how exactly does this work? Especially if my computer is here on the east coast of the US and I want to access a website based in like France. How is that working completely? They don't just beam the code right to me, right? So how this works is it's actually very similar to the postal service. Each computer has its own IP address, which is like a regular address. In fact, let's see what mine is. You can actually do what I'm doing right now and see what yours is. Just look up my public IP address. Maybe just my IP address. There we go. So this is my current IP address. I know it doesn't really make much sense, but these series of numbers tells people all over the world my approximate computer's location, and it gives people the ability to send me HTML code and files. In fact, yeah, if you just go to Google and search up my IP, Google will be able to figure out your IP. And this makes sense because if Google is sending the code for this page back at you, it has to know where to send it. And that's this IP right here. So now going back here. If it makes sense that each computer has its own IP address, so does each website. So if a website is just a bunch of code, right? That means that code must be stored on someone's computer. So a website is basically a bunch of code that's stored on someone's computer. It's right here on the creator's computer, and you want to be able to access it. So which means you have to know the IP address for that computer as well. And that's exactly what happens. So if you type in google.com, right? What's actually happening in between that time is there's something called a DNS, a domain name system, or a domain name server, which converts this address right here, google.com, into something that looks like that. And then that is what the computer uses to send it. For example, we can actually figure out what that is. So if you open this is the terminal on a Mac or command line on Windows, you can do what's called pinging. So as long as you're connected to Wi-Fi or a data connection with good connection, good internet, type in ping and then any website. So ping google.com. And you can see here, so it's still getting a lot more data from google.com, since google.com has a huge range of IP addresses and a lot of data on its page. But if you just take this, I just want this, I'm gonna copy this. And notice how this proves it. If I just put this in here, nope, I added some parentheses right there. Do you see that? Let me just show you again. So if I just type in this IP address and then I just hit enter, it goes straight to google.com. It's kind of cool. But it does show you how some of the underlying systems work. Let me just end this before it crashes my computer. But there we go. Okay. So we talked about this. Yeah, it's like a phone book for the internet, and it converts a link such as oranges.com to find the IP address of the computer that's storing oranges.com. So your router, so if you don't know what a router is, it's basically it's a physical device. It's a hub that stores your internet connection, and every website request is bounced through the router. So if you don't know where a router is, you can ask your parents, and they'll probably be able to tell you where it is. But you can basically see that whenever you're trying to access a website, all the requests go through the router. So speaking of, how does the router actually send that request? So now that you know that the IP address you want to go to, so google.com is that weird 172.217.3.1110, you know that's my destination. So now the router has to figure out, what am I going to do to ask google.com to send me its website code? So it sends data there in what's called packets. And of course, if all the data was sent at once, remember, these are huge website files. You can see all the code inside here is a pretty big amount of data comparatively. But if all the data was sent at once, it's kind of like traffic on a highway. If you're trying to send all the cars squeezed together, there's only a certain amount of lanes that cars could go on. So instead, what the router does is it splits your data into many different packets. So it splits all the HTML code on this site into some number of packets, each containing a certain amount of code. And they all take different routes or different lanes, different exits off the highway, and they eventually all bounce off to the target destination. But how do all the packets know how to get there, and how do they not crash into other packets on the highway? So that's how people made up a set of rules called TCP or IP protocols to ensure safe and efficient data transmission. So if you just go to this website right here, cryptoit.net, it has a pretty cool graphic for how this works. Let me just skip that. So this is how it all works. You don't have to know any of this. This is just to show you how complicated the system is and how all of the stuff in here is happening in literally fractions of a second. If you were to type in a website and hit enter, all of this stuff, including this stuff, is happening in literally less than a second, which I find kind of crazy. But these are basically all the TCP IP protocols. You can think of these as like driving laws for your packets. Like they have speed limits and all sorts of stuff that tell them where to go and similar to traffic rules and highway regulations. So eventually when all your data gets to oranges.com, you're over there and you're asking oranges.com or google.com, can you please give me the HTML code for your homepage, like Google search page? Then they get the request and they send more packets back your way containing the website information to your computer. And eventually, once it hits your computer, your browser runs the code, and eventually you get a beautiful looking website like this. So if you didn't get it, what I said, I know I was talking a bit fast there. You can go back, try to listen to what I said again. And there's also some great videos on the internet summarizing this in a bit longer video. I'm trying to squeeze this into a shorter amount of time. But let's move on to the next part. So I was talking a lot about website requests and how you're asking a website to do something for you to send you back code. There are two big types of requests, and they're called GET requests and POST requests. So GET requests are used to receive information like HTML code. So if I was trying to access the web page, let's actually go to oranges.com. I'm sure you guys are just waiting to listen. This is oranges.com, everyone. Look at this awesomeness. Not the best website you can see, but it's great. So yeah, if I wanted to actually access orange.com, what my computer is doing is it's sending a GET request. And it's used to receive information. A GET request is simply, hey, my client, my computer wants to receive the HTML code for this here website. Can you please send it over? That's all it is. That's a GET request. And then the server or the computer on the opposite end that has the code for oranges.com sends a copy of it back your way. And then your browser, so in this case for me that's Chrome, runs it. So that's all a browser is actually. I don't think I mentioned that. A browser is just a way to run code. Just like you have the Oracle's Java machine to run Java code or the idle to run Python, a browser is literally where you run HTML code. So that's kind of cool. And then you have the POST requests, which are the other one. And that's how you send information to a website. So for example, say I wanted to share this document. Actually, let me not do that. A good example. Actually, here's a good example. So let's go to google.com again. So we sent my GET request and I got the code back for google.com. But what if I want to search for, sure, let's go the density of salt, because why not? How does Google get the information that I want to search for the density of salt? That is called a POST request. And that's how you send information to a website. So an example here would be to log into your email account. You send a POST request with your email and password over to your email server, and then they use that to check against it and see if your email is correct. So here I looked at the density of salt, and this information was sent via a POST request to Google, and then Google saw it, and then it sent back the correct HTML code for this search query. So you can see that salt is sodium chloride and has a density of 2.16 grams per centimeter cubed. And the internet and all the TCP IP protocols, this entire thing, including the POST request and the GET request, finished in literally 0.56 seconds. Look at how far we've come. Okay, now going back here. So one thing I want to notice, if you went back here, that's the HTML code, the CSS, the JavaScript, all are coming in these GET and POST requests. So for example, if I were to quickly, you guys probably know what this is. It's an inspect element. Let me inspect. Oh, text copying has been disabled. That's fun. No, let me do it here. There we go. Inspect element. So you can see how, don't worry, there's a bunch of stuff that's going to appear. This is HTML code. All of this stuff here is HTML code. And you can see when you hover over each thing, it tells you what it codes for. So over here, this is coding for a bunch of different stuff. Don't worry if you don't know what this means yet. Over here on the right, you'll see CSS. And then JavaScript, I'll talk about after because it's not really being covered in this course. But one thing you should know is that Java and JavaScript are not the same thing. Just like grapes and grapefruits are not the same thing, Java and JavaScript are two completely different programming languages, so don't come up and start talking about them the same thing, then people are gonna think you're not very smart. So don't do that. Please don't do that. I get very annoyed when people do that. So I think one of the last things we're going to cover today are the different parts of a website that you can see. So the main parts of a website are a title. So I'll do it on Thinkific here. So your title would be up here, web development. Actually, a more general title is what comes up here. So you can see how each website has a tab title, which basically comes up on the tab. So these are tab titles, and these are the website's big title. Web development is the title of this page. Then after that, you have your navigation bar. This is a navigation bar. Lets me navigate between different web pages within the website. What else? We have a header. Some websites don't have headers, but headers are normally, you know what a footer is? Like this is a footer, for example. A header is just the same thing as a footer that goes on the top. So this is a type of header. Then you have the body. The body is basically the entire website besides everything else. So the body consists of all of this stuff here. All the meat and potatoes of your website. All the text, the images, the videos, the buttons. These are all on the body of the web page. And then finally you have your footer. I talked about the footer. The footer is just over here. So now you have the footer. So now let's go into what's called HTML. So this also is an acronym. It stands for Hypertext Markup Language. So you have the H, the T, the M, and the L. And that's used to add the skeleton or the structure of the web page. So HTML documents are made of what's called an HTML element. Elements are also called tags. It's another thing people call them. And they're made up of a less than symbol and a greater than symbol. And the stuff in between is the tag. And the elements are the things that you put on your web page. So an easy way to see different elements in action, I kind of showed you this already, gave you a sneak peek, is to go to inspect element. So this should be available on basically all your computers, but I know for a fact it's available on the Chrome browser. So if you have Chrome, Chrome is a wonderful browser. So if I were to right click over here and then go down to inspect, this opens this huge developer tab. So don't click around. Don't worry about what's going on here. It's huge. But if you quickly hover over each different thing, these are all different HTML tags put together. And this kind of shows you how even the biggest websites on the internet are just made up of a whole stack of HTML tags put close together. In fact, if I click this, you could probably, there's probably too many to see, but somewhere hidden in here would be a title tag. And then you have your body. Remember we talked about the body already. You have all of these different tags that are used. So don't worry if you don't know anything about HTML yet. The one thing I was hoping you were taking out of this lesson was the sheer amount of processes that are going on in the internet and how fast they're happening. So like Google is really good at doing this. A quick Google search for oranges. Clementines. Let's do clementines. I know we have clementine fans. But look at that. It all happened in 0.69 seconds, which is nice, but really fast. Let me see. I think that might be all. So let's just quickly recap what we covered today. So we talked about Thinkific, how the course will run. REPL.it is an online editor. I'll quickly pull that up. That wasn't really important right now. It just lets you type in code and run code on the internet. This is REPL.it, by the way. Neha will take you through what that is on the next video when you actually start learning what HTML is. But these are the multitude of processes that are going on the internet. Then about websites, inspect element. Then here are 2 practice quizzes you can do. So just click on these links and you can go to the quizzes. So for the internet quiz though, I didn't go into as much depth as the quiz does. Everything you need to know to answer the quiz is on Thinkific. So if you want to quickly go through, I think it's section 1.1. Yeah, 1.1. The quiz is also here for you. So if you just were to take this quiz right now after watching this video, you might get a few questions wrong because I did not go into as much depth as to fit into a 20-minute video. But the second quiz, the web page quiz, you should be able to answer. And you should have an easier time with this one. So the last thing I want to cover is HTTP versus HTTPS. So just like TCP and IP, these are security protocols for how information is transferred over the internet. So you can see if I click on this lock. This lock, come on. Okay, it's almost there. All right, here. So if I click on this log, it says connection is secure. What this represents, actually, if I click on this, it should appear here, https://. So what that represents is it's instead of just normal HTTP, which you'll find on some websites too, this is HTTPS, which is a more secure way of transferring information between your computer and the computer that the code is stored on. So if I were to go to, I think oranges.com is not HTTPS. You can see it says not secure up here. It doesn't mean it's not secure, but it just means it's possible for people to interfere within your connection. Just like you can have a hold up or a traffic jam. Things can happen along HTTP, but it's a lot more secure over HTTPS. And that's what you have to take away from that. So I'm approaching 20 minutes over here, so I just wanted to say thanks for watching. And my partner in crime, Neha, will take over the next video, and she'll introduce to you a few basic HTML tags, and it'll get you further on your way to creating your first website. Thanks, and have a great day.